Hello, I'm doing section 10.2, objective 1. What we're going to do is we're going to convert from exponential notation into radical form. So this is exponential form, and this is what we call radical form. So we're going to go from this notation into the notation on the right-hand side. This only works if the nth root of a is a real number. Again, if a is negative and n is even, which is 2, 4, or 6, then this is not a real number. So we have one of those on here. Okay, so here's just a couple examples. Again, we're going to go from exponential to radical form. So here's the first one. Actually, I'm going to start with this one. This one is, the index is 2, so this is the square root of 9. If it's square root, we can either put a 2 there. If we don't put a 2 there, and there's no number there, we just identify it to be a 2, a square root. Okay, so either way. And the square root of 9 we know is equal to 3. Okay, let's go to this one over here now. This one, the index is 3, so this is a cube root of 8, and the cube root of 8 is actually equal to 2. Okay, now let's compare these two. These are both fourth roots. So this one, the negative's on the outside, this one's on the inside of the parentheses, so they're just a little bit different. So this one, the negative's on the outside, so I'm going to put the negative first, because that's on the outside, and I'm going to write this in exponential form. I'm sorry, it's in exponential form, we'll put it in radical form. So again, this is on the outside. And we do know the fourth root of 81 is equal to 3, so this is equal to 3, so the whole answer is equal to negative 3. Now this one's a little bit different. Because of the parentheses, this whole thing is going to go inside the radical. So this would be the fourth root of negative 81. Now we talked about if it's a real number, if the index is even, and this is negative, we can't find it. It's not a real number. It's a complex number that we'll talk about a little bit later. So this is not real. Okay, here's another example. Again, it has a parentheses, so I'm going to put the cube root of negative 64. Okay, this time the index is odd, so we can't actually find it. That's equal to negative 4. And again, the reason why is because negative 4 cubed is equal to negative 64. Okay, finally, this last one, we're going to find the fifth root of 1 over 32. Okay, so we know that, I know from the previous pages, or just by example, 2 to the 5th is equal to 32. So what I'm going to do is I'm going to actually separate these two, which is one of the rules we'll talk about a little bit later on. Separate the numerator and denominator, which we can do. The fifth root of 1 is 1. The fifth root of 32 is 2. So the answer is 1/2.